Okay, Assalamualaikum and hello to all. So for today, we are going to continue our lesson in chapter 8. So today we are going to learn in subtopic 8.2 entitled Properties of Lights and the subtopic 8.3 entitled Reflection of Light. So you can refer to your textbook page 229. So before we proceed with our lesson for today, so let's recap our previous lesson during our previous class. So let's see these slides, this slide attachment here. So wait. Okay. So please take a look at the slide. So as you can see from the slides, so during our previous class, we already learned about the use of a mirror. So as you can see here, we learned about the plane mirror, where we use this kind of mirror to see our face in everyday life. So we got two kind of images, a real image, which forms on a screen, and the virtual image, which cannot be formed on a screen. So we got three types of mirrors: convex mirror, plane mirror, and concave mirror. Convex mirror in bahasa we call it as cermin cembung, and then plane mirror ialah cermin satah, and then the concave mirror we call it in bahasa as a cermin cekung. Okay, and then these the difference between the concave and the convex mirror. So convex mirror is a cermin cembung. Jadi kalau kamu tengok di sini, as you can see there, for the which one is the convex mirror and which one is the concave mirror. So for convex mirror, which are the cermin cembung, this is a convex mirror and this is a concave mirror. So by using the convex mirror, so it's actually it can help to enlarge the pictures, the image. So it always used in supermarket or maybe in dangerous corner of a road. But this one is the concave mirror, where it can be used for for the dental use, or maybe for apply makeup. Okay, this is also the difference between the concave and convex mirror. So you also learn about the usage of the plane mirror. For this one, plane it helps a dancer to correct their movement, and then usage of a plane mirror so make rooms look spacious like this one. Okay, and then for the concave mirror, which are cermin concave mirror ialah cermin cekung. It used to magnify the image, make easier for someone to apply makeup, and then it also used by a dentist. And the patient's teeth looks bigger and closer. And this one is another usage of the convex mirror used at the dangerous corner of a road, and also can help the shopkeeper to see every corner to prevent any theft happen in their supermarket. Okay, and this one is the application of the concept of reflection of light to the certain optical instruments such as periscope. So the periscope use the concept of reflection of light here. This is a plane mirror, so it will reflect the lights from this is the object. So the lights from here, from the image, will reflect to the second plane mirror, and then it will reflect to our eyes, so we can see that object. And this is kaleidoscope, which use the concept of reflection of light. So for today, we are going to learn about the properties of lights. So you can refer to your textbook, page 229. So as you can see here, why do we see lightning before we hear thunder? So we will get the answer based on the properties of light, which we are going to learn in this subtopic. Okay, actually, the first properties of light is the speed of light is 3.0 times to the 10 to the power of 8 meter per second. So the light travel much faster. Uh, Light travel much faster than sound. So that's answer for the previous situation. Why we can see lightning before we hear the thunder? It is because the light travel much faster than sound, where the light speed is around 3.0 times 10 to the power of 8 meter per second. That's the reason why. As when you see the thunder during the rain, so you can see that the lights first, the thunder first, and then you can see the lightning first, and then maybe after a few seconds, then you can hear the thunder. That's the reason, because of the speed of light. Okay, for the second properties of light is light travels in straight lines. Uh, So as you can see from the picture, cahaya ni bergerak secara lurus. So light travels in straight line. There is no kind of the lights which travel in the not in the straight lines. So most actually all the lights travel in the straight lines. And then the third properties of light is actually how shadows are formed, where the sunlight travels in straight lines. So ring is an opaque object. Sunlight cannot pass through it. And when light is blocked, shadow is formed. Okay, as you can see here, bagaimana satu bayang itu terbentuk, it is because based on the sunlight travels in straight line, and the ring is an opaque object, maksudnya ialah objek legap. So because of that, the sunlight cannot pass through it. Cahaya tidak dapat melalui objek yang legap, and when the light is blocked, so what we call as shadow is going to form. This is the reason why you can see shadow here, because the light cannot go through the opaque object. So because of that matter, so it will form a shadow, as you can see in this picture. Okay, the length of shadow will be different based on the position of sun. So as you can see from the picture, during the morning, you can see the position, the length of the shadow here is quite long. At noon, the length of the shadow is quite short, and during the evening, the length of the shadow is quite long. Depends on the position of sun. In the early morning, yes, most of the in the early morning, the length of shadow will quite long compared when we are reaching the noon. So let's say dalam jam 8 pagi. So the our shadow is very long. When the time is now around 10 in the morning, so the length of the shadow will become short. At 11, the length of the shadow will become shorter. And around 12 noon, so maybe in the 12 noon, the shadow will be the shortest one, like this one. When the evening comes, like like 2 p.m., so the length of the shadow will become long. And then in the 4 p.m., it will become longer, and maybe at the something around 6 p.m., 6:30 p.m., the length of the shadow will become longest one for that day. But the way where the shadow will be formed is based on where the sun is. Uh, so during the morning, the sun rise from the east. So means that the shadow will be at the west. And during the evening, the position of the sun is at the west. So the shadow will be formed at the east. During the noon, actually, the position of the sun is really above our head. That's why the length of shadow is just short like this one. Okay, this is the application of the concept of shadow. This is the sundial ataupun jam matahari in bahasa Melayu, in bahasa Malaysia. Uh, and then we got the shadow play, in bahasa apa ni? Wayang kulit lah. This shadow play is very popular in Kelantan, in the west, in the east coast, in the east coast of the in the east coast states of Peninsular Malaysia, like Kelantan. So actually, how the shadow play can be can be can be formed by using the concept of shadow. Okay, so we have just done with the subtopic 8.2, properties of lights. So actually the properties of light is all, the first thing is the speed of light is around 3.0 times to the 10 to the power of 8 meter per second. And here we can see that actually the light travel much faster than sound, and then light travels in straight lines. And from the properties of light, we can see how the shadows are formed. Okay, this is the application of the concept of shadow, like shadow play and the sundial. Okay, now we continue to the next subtopic, subtopic 8.3. So you can refer to your textbook, page 230. So for this subtopic is entitled Reflection of Light, or in bahasa apa? Reflection, pantulan cahaya. Okay, as you can see here, in the figure 1, there is a torchlight here. When we switch on the torchlight, so there is a light bounce off the surface. We can see the lights here, so it will reflect back the lights when it go through the what we call it, plane mirror. So as you can see here, we got the angle of incidence and angle of reflection, and this is what we call as the normal line. Yeah, this is a normal line. So based on this one, we got the angle of incidence ataupun sudut tuju, or in this one is the angle of reflection ataupun sudut pantulan. Okay, as you can see here, light bounces off the surface of an object. So as you can see here, when the incident rays go through the smooth surface, it will reflect rays like this one. But when the incident rays reflects at the rough surface, or so the reflected rays will become like this one, maybe to this macam ke sini, or maybe ke sana. It will reflect to the, anyways, depends on the shape of the surface. So as you can see here, the smooth water surface like this one, so you can see the reflection of the mountains here. So during the wavy water surface, so you cannot see clearly the reflections from the surface of water. So this is the law of reflection. So the incident ray, reflected ray, and the normal all lie on the same plane. This is incident ray. This is an incident ray. Yeah. Okay, this is an incident ray, and this is a normal line, and this is a reflected ray. So actually, reflected ray ni in bahasa we call it as sinar pantulan, and incident ray in bahasa we call it as a sinar tuju. This is a normal, atau we call it as a normal line. So this one, so from this one it will form the angle of incidence, or in bahasa we call it as a sudut tuju. And this one is the angle of reflection or sudut pantulan. So actually, as you can see here, when we got the ray, so this is, we call it as an incident ray. When it go through the plane mirror, it will reflect back to form the reflected ray. So because of this kind of the reflection, it will form the angle of incidence here. So the angle of incidence, it's from the incident ray until you reach the normal line. So this kind of refracted ray will form also the angle of reflection. How we want to calculate the angle of reflection is from the refracted ray until this normal line. So the normal line with the plane mirror, it will form around 90 degree. Please don't calculate, please don't measure the angle of incidence from the plane mirror to the incident ray, or from the plane mirror to the reflected ray. If you want to measure the angle of reflection, you should measure from the reflected ray or from incident ray to the normal line. So actually, the angle of incidence should be same, is equal to the angle of reflection. Let's say this is a 30 degree for angle of incidence, so means that the angle of reflection also 30 degree. Okay, now we go to the applications of reflection of light. So as you can see here, these are the certain application of the reflection of light. These are the cones always used on roads. So this one can be reflected, so you can see during at night, like this one. And this is what we call it as, saya tak ingat apa orang panggil ni, tapi I always call it as a jacket, a reflection jacket, but I didn't know the exact name of this jacket. And the function of this jacket, it will reflect lights. So when there is a light, uh, when there is a light, go through this jacket, then it will reflect back to our eyes. So we can see this jacket. So we can see there is a people there. So same goes to this signboard. So as you can see, most of this one, the colors, the words, the colors for the words, this one can be reflected. So when you try to high beam your car lights, so you can see this one, because it will reflect back the light. Once the lights go through this signboard, they will reflect back to our eyes, so we can see this information clearly. Okay, so that's what we learned in this topic. So Uh, so let's recap what we learned in this subtopic. This is in this subtopic, you need to know about the angle of incidence and an angle of reflections. So the light bounces off the surface of an object. So when there is an incident rays, so it will be a reflected rays as well. So this is how the incident rays will reflect as a reflected rays in the smooth surface, and this one, how the incident rays will reflect back as a reflected rays in the rough surface. This is an examples. In the smooth surface, you can see the image of mountains clearly. Instead, in the wavy water surface, the image not so clear. So in law of refraction, it will be the incident ray, and then we have a reflected ray and the normal, which are all lies on the same plane. Another one would be the angle of incident, I, which is equal to the angle of reflection, this one. I told you before, if this angle is around 30 degree, which means the angle of reflection also 30 degrees. It should follow this law of reflection where the angle of incident I is equal to the angle of reflection R. If you want to measure the angle of incident, please make sure that you measure it from the normal line to the incident rays or to the reflected rays. Don't ever try to measure from the plane mirror to the incident or reflected ray, because it's obviously wrong. If you want to calculate or if you want to measure the angle of incidence or reflections, so you need to measure it from the normal line to the both angle of to the both reflected ray and incident ray. And these are the application of reflection of light, like these cones, reflected cones, and the the mileage signboard, especially in highways or maybe in any roads, any roads in Malaysia, in the world, in the all over the world. Okay, so we've done with our topics for today. So I hope you will understand, or you will understand all of the lessons for today. So thank you very much. So in the next class, we will cover for this subtopic, which is the refraction of lights. Okay. Thank you for listening. Bye.